Hello everyone, welcome you all to this new video. So in my previous video, I had discussed with the classification of networks, that is local area network, wide area network. Then under wide area network, we have seen with the point-to-point network and multi-point networks, and we have seen with the circuit switched and packet switched network, internets, the uppercase and lowercase internets. We have seen all of them in the previous video. Those who have not seen that video, please go and watch it because I've covered a lot of concepts in that video. So this is the fourth video of this module where I'm going to be discussing with one very important concept from the exam point of view. Okay, I'm telling you now itself, this is the most important concept. So you should be thoroughly learning this question. Okay, because in your college also, I guess your lecturers might have told you in this module this is a fixed question. Okay, so I'm also telling you the same. This question is the fixed question, important question. It would be definitely arriving in the final exams, internals, everything. Okay, for 10 marks for sure. So please make a good note of it. Question. This question I'm going to be explaining it now. TCP/IP protocol suite. Okay, so we are having a lot of things to be discussed in this TCP/IP protocol suite. What do you mean by this suite? And its layered architecture, where in this we are having the it is a five-layer architecture. It consists of five layers, and encapsulation and decapsulation of data packets would be happening in these five layers with respect to switches and routers. Okay, so how it is getting interconnected to each other with the help of the networks, internet, everything we are going to be seeing in this video. So please stay tuned till this video till the end. Do not skip any part of the video. Like this video before you move further and subscribe to our channel if you have not yet subscribed. Okay, so now let us get to the concept now. TCP/IP protocol suite. So now that we have known about the concepts of protocol layering and logical communication between layers, we can introduce the TCP/IP, that is called as Transmission Control Protocol or Internet Protocol suite. Okay, so this suite, which is a set of protocols organized in different layer, it is used in the uppercase internet today. Okay, it is a hierarchical protocol which is made up of interactive modules, each of which provides a specific functionality. Okay, it would be having a different set of modules. So we have already known the definition of protocol. Protocols are basically a set of basic set of rules which is taking place between the data transmission, in between the data packets. Okay, so those basic set of rules would not be possible without the help of these interactive modules. Okay, so each of them provides a specific functionality. Okay, so each model has a specific function which would be getting reacted. So the term hierarchical means that each upper level protocol is supported by the services provided by one or more lower level protocols. The original TCP/IP protocol suite was defined as four software layers built upon the hardware. But today, however, TCP/IP is sort of a five-layered model. Okay, it is a five-layer model. So this is the layered architecture here. So to show how the layers in the TCP/IP protocol are involved in communication between two hosts, we assume that we want to use the suite in a small internet made up of three LANs. Okay, the three LANs are also be calling as a linked links, or it is also called as a link layer switch. Okay, we assume that the links are connected by one router as shown in the figure 1.2 here. Okay, so this is that figure. That let us get to this part later. Now this is the layered architecture. See here, it consists of original layers and layers used in this particular architecture. Okay, so the main five layers which you need to be focusing on is here. These are the five layers. Okay, don't focus here, just see here: application layer, transport layer, network layer, data link layer, and physical layer. Okay, so this is the order in which these layers are getting incremented. First comes the physical layer, data link layer, network layer, transport layer, and the application layer. Okay, so this is the uppermost layer. Application layer is the uppermost layer, and the physical layer is the lowermost level in the layer in this architecture. So this diagram you need to be noting down. Now come to this diagram, that is communication which is happening through the uppercase internet with respect to this source and destination. Okay, so here mainly they are using two hosts here. One is called as a source host and another one is called as a destination host. How it is getting traveling in these five layers with respect to one router and two of the switches. Okay, which is present. Let us see here. So these are the five layers. It gets started from the uppermost layer, that is application layer, and it travels down to the physical layer. So this is called as decapsulation, which is taking place, okay, which is coming from application to physical, okay. So from uppermost to lowermost, the lower direction, this is called as decapsulation, and here it would be going from physical to application, this is called as encapsulation, okay. So that for that I'm going to make a dedicated video in the next video. Now don't think about that, just see the path about how it is getting traveled. Firstly, it starts from source A. Okay, it goes through the application layer. Then whatever the application sources are required, the data sets and all the data packets are getting transported into the transport layer. So the functioning of this transport layer is simply that it would be getting transported to the network layer. Okay, so whatever the data packets are present, which is getting from the application layer, that would be getting analyzed and it would be going towards the network layer. So in the network layer, it would be going through the router here, which is present here. You see here, it would be going through the router, and in the router, the connections would be made based on the links which is present in the different set of systems. Okay, so those connections are made in this network layer, and it comes to the data link layer. In the data link layer, it would be consisting of switches. Okay, so from those switches, it would be connecting to the physical layer, and it would be getting traveling in this path. Okay, so this is the communication which is taking place from source to destination here, from source A to destination B. Okay, so these are the links which is present here, and it is getting connected to the router. There are basically three links: the link 1, link 2, and link 3, and these are the source source host and the destination nodes. This is not required. This is the uh, middle host that is happening in between the communication of A to B. This is not required. Just focus on the this straight line here. This line, in this line, the communication is taking place. Okay, so we don't have any connection between application and transport layers. So that's why it is connected logically. So that logical connection part is going to be explained in the later stage of this video. So this is the diagram. Just note it down for communication which is happening through internet. Okay. So these are the explanations which I have told you. So now let's get to the all the layers which is present in the TCP IP protocol suite. So these are the five layers as I've told you: application, transport, network, data link, and physical layer. Right? So yeah. So description of each layer, how it gets transferred with respect to the routers and all. First is called as physical layer. We can say that the physical layer is responsible for carrying individual bits. Okay, it is responsible for carrying individual bits in a frame across the link. Okay, although the physical layer is the lowest level in the TCP IP protocol suite, the communication between two devices at the physical layer is still a logical communication. Okay, so whatever the communication which is taking place from source to destination is a logical communication. Okay, because the communication is not wired, but instead of that it is wireless, which is taking place from layer to layer. So that's why it is a logical communication, because there is another hidden layer, that is the transmission media, which is present under the physical layer. Two devices are connected by a transmission medium that is called as a cable or air. For wired communication, it is cable, and for wireless, it is air. We need to know that the transmission medium does not carry bits; it carries electrical or optical signals. So the bits received in a frame from the data link layer are transformed and sent through this transmission media. But we can think that the logical unit between these two physical layers in two devices is called as a bit. There are several protocols that transform a bit to a signal. We discussed them in part 2, where we discussed the physical layer on the transmission media. So that is not required now. So basically, one brief idea you could be giving for a physical layer, that is, it is responsible for carrying individual bits. That is whatever the input data which we get, which we are going to be getting from the source host, and it would be getting converted to bits, and based on that individual bits, it would be getting transported one by one to each of the layers through the process of decapsulation. Okay, then those individual bits would be happening in a frame across the link, and the communication is happening with respect to one hidden layer that is called as a transmission media, which is just present under the physical layer. Okay, two devices are connected by this transmission media, and that transmission media would be cable or air, that is with respect to wired or wireless communication which is taking place. Okay, so the logical unit between two physical layers in two devices is called as a bit. So yeah, this is basically a physical layer. Next, let's get to the one more kind of layer that is called as a data link layer. We have seen that the internet is made up of several links, LANs and WANs, connected by the routers. There may be several overlapping sets of links that a datagram can travel from the host to the destination. The routers are responsible for choosing the best links. So here in the data link layer, that is basically it would be linking all the data packets which would be present in the source host, and that is getting traveled in from the physical layer, transport layer, and it would be from the physical layer it would be going towards the data link layer where all the datas are getting linked to one another, and it would be coming together in a form of a packet, and that packet is stored inside the router in the network layer. Okay, so that is basically meant by the data link layer. So there are some other explanations here, you just see it down. Okay, I'm not going to read it. Next is the network layer. The network layer is responsible for creating a connection between the source computer and the destination computer. Okay, so this layer is a very important layer where it is responsible for creating a connection between the source and the destination, and that connection is happening with respect to a router. Okay, so that's why it is a host to host communication. We are having two hosts, source host and destination host. Now in the data link layer, the physical layer is responsible for traveling of the data, right? Now data link layer, what it does is, from the physical layer whatever the data is getting transferred, that is the bits, that would be converted in form of packets or datagrams. Okay, all the data would be stored together in the data link layer. All the data would be linked and would be stored in the form of packets. Now those packets are separated, right? Now in order to make it together, we should be using the network layer where these data packets are getting stored in one connect in one point. That point is called as a router. Okay, all the data packets are connected through a router, and then it is directly getting connected from source host to destination host. Okay, they are interconnected in the with the help of a router. Okay, so however, since there can be several routers from source to destination, the routers in the path are responsible for choosing the best route for each packet. Okay, so for each packet, whatever the routers are present, that would be responsible. In this case, in this diagram, there is only one single router, so that's why we don't have multiple routers. So this is only one single router where the data would be getting transferred, right? Yeah, so this is also called as host to host communication. And then next layer is called as the transport layer. So here transport layer, what it does is, it is a end-to-end connection. Transport layer as source host gets the message from the application layer, encapsulates it in the transport layer packet called a segment or user datagram in different protocols. That is, now three layers are over. Now in the network layer, all the data packets are getting stored in the router. Now from that router, and one link is getting created, one link has been created from source to destination. Now whatever the required data which is needed to be transferred from source to destination, that is done with the help of the transport layer. It is end to end encrypted. It is passed through the transport layer with the help of the transport layer packet, which is called as a segment or the user datagram. Datagram is basically the required data set which is required to be going towards the destination. Okay, so that is called as the transport layer. It is an end-to-end device. It does not have any of the devices in between. Okay, so that's why we would be having direct connections in transport as well as application layer. Okay, so application layer shows the logical connection between the two end-to-end transport layers. That is, the two application layers exchange messages between each other as though they were a bridge between two layers. However, we should know that the communication is done through all the layers. Okay, so the communication at the application layer is between two processes, two programs running at this layer. To communicate, a process sends a request to the other process, and receives a response. Process to process communication is the duty of the application layer. That is, from the transport layer, now the required data is getting sent from source to destination. Okay, so based in that uh, medium of time, whatever the required applications which is to be transferred to the destination part, those application set would be getting decided by this application layer based on the proper communication in between the two hosts. Okay, yeah. So this is all about the five layers under TCP/IP protocol and the brief explanation about the TCP/IP protocol suite. So I have not completely explained this, just to have given one brief explanation. If you want to add some more points, these notes I'm going to be pinning it in the description. This is from the AZ documents. Okay, you could be going to their official website and downloading these notes. You would be getting all the five modules notes. Okay, so this is one standard notes where most of the students prefer reading. Me myself, I'm preferring these notes because this is very easy notes with not much pages, around 20 to 30 pages of each modules. Okay, so that's why I prefer these notes. I'm going to be putting in the description. Download it and read it. Okay, yeah. So that's all, guys. Thank you.